Space. It is a hostile environment devoid of gravity, oxygen, and shielding from radiation. Extreme temperatures, microgravity, and vacuum pose challenges to human survival. However, space exploration offers opportunities for scientific discovery, technological advancements, and expanding our understanding of the universe. Once astronauts reach space, they enter an environment of microgravity where the effects of gravity are significantly reduced. This absence of gravity's constant pull on our bodies leads to fascinating adaptations. One notable change occurs in the redistribution of bodily fluids. In the absence of gravity, fluids tend to shift upward within the body. Normally, on Earth, gravity pulls fluids downward, helping to distribute them evenly throughout the body. However, in microgravity, this mechanism is disrupted. As a result, fluids accumulate in the upper body, leading to a puffy face appearance and fluid buildup in areas like the head and neck. This phenomenon can also cause changes in blood circulation. Without gravity to assist in the return of blood to the heart, fluids may pool in the upper body, leading to a decrease in the volume of blood circulating through the lower extremities. Astronauts may experience a reduction in lead volume and increased congestion in the upper body. In space, the absence of gravity can have an effect on human height. On Earth, gravity compresses the spine and causes the discs between vertebrae to slightly flatten, resulting in a temporary reduction in height. However, in the microgravity environment of space, this compression is reduced, allowing the spinal discs to expand. As a result, astronauts often experience a temporary increase in height while in space. This change can range from a few centimeters to a couple of inches, depending on the individual. However, once astronauts return to Earth and gravity is reintroduced, their spines gradually compress again, and they return to their PI flight height. Space travel can have intriguing effects on the human eye. One phenomenon observed among astronauts is known as spaceflight-associated neuroocular syndrome. In the microgravity environment, fluids in the body tend to shift towards the upper body, including the head. This can result in increased fluid pressure around the optic nerve and changes in blood flow to the eyes. These alterations can lead to visual impairments such as nearsightedness and swelling of the optic nerve. Some astronauts have experienced blurry vision and difficulty focusing during and after their missions. Scientists are actively studying these eye changes to better understand the mechanisms and develop countermeasures to protect astronaut vision during long-duration space travel. Space travel has a bone-chilling effect on astronauts' skeletal systems. In the weightless environment of space, where gravity takes a vacation, bones suffer the consequences. Without the constant force of gravity to bear, bones become lazy and begin to lose density, resembling a fragile lattice rather than a sturdy structure. This phenomenon, known as space-induced osteoporosis, occurs because bones no longer experience the necessary stress required for maintenance. As a result, astronauts returning from space missions often face weakened bones, similar to what one might expect from a lazy couch potato. To combat this, exercise regimes and specialized diets are implemented to help astronauts regain their bone strength upon re-entry into Earth's gravity. Space travel has a fascinating impact on the shape of the heart. In the microgravity environment of space, the heart experiences a peculiar transformation known as the space heart. Without the constant pull of gravity, the heart doesn't have to work as hard to pump blood against Earth's gravity. As a result, the heart gradually adapts to the reduced workload and becomes more spherical in shape, resembling a rounder, ball-like structure. This change is an intriguing physiological response to the unique environment of space. However, upon returning to Earth, the heart gradually resumes its normal shape as it readjusts to the effects of gravity, bidding farewell to its temporarily inflated appearance. Space travel exposes astronauts to various forms of radiation, which can have intriguing effects on the human body. The Earth's atmosphere and magnetic field provide significant protection from radiation, filtering out and deflecting a large portion of incoming cosmic and solar radiation. Additionally, the presence of the Earth's surface and structures further attenuates radiation levels. However, in space, there is no such shielding, resulting in a higher radiation dose. The primary source of radiation is galactic cosmic rays, high-energy particles from outside our solar system. These particles can penetrate spacecraft and human tissues, potentially damaging cells and DNA. While shielding and protective measures are in place, prolonged exposure to galactic cosmic rays can increase the risk of cancer, cataracts, and other radiation-related health issues. Interestingly, Some studies suggest that cosmic radiation might accelerate the aging process, leading to premature wrinkles, muscle loss, and even cognitive decline.